Hello everyone, welcome to this video on circuits and networks. This video is about Z parameters or open circuit impedance parameters. As you all know, there are four variables for a two-port network and they are V1, I1, V2 and I2. V1 is the voltage at the input port, I1 is the current entering the input port, V2 is the voltage at the output port and I2 is the current entering the output port. And out of these four variables, two variables will be dependent and two variables will be independent. And for a two-port network with Z parameters, the dependent variables are V1 and V2 and the independent variables are I1 and I2. The voltage V1 depends on current I1 as well as current I2. So V1 can be written as a function of I1 and I2. Similarly, voltage V2 depends on current I1 and I2. So we can write V2 is a function of I1 and I2. Now we can write the equation of two-port network with Z parameters. The voltage V1 is dependent on I1 by a parameter Z11 and is dependent on current I2 by a parameter Z12, and the voltage V2 is dependent on current I1 by a parameter Z21 and it is dependent on current I2 by a parameter Z22. So these are the two equations of two-port network with Z parameters, and these two equations are very important. And we have written the parameters as Z11, Z12, Z21, Z22, etc. because upon calculation we will see that these are all impedances. So this impedance can be represented by the letter Z. So we are representing it as Z11, Z12, etc. And the unit will be ohms. Now we can write this in matrix form. So this can be written as V1, V2 is equal to Z11, Z12, Z21, Z22 into I1, I2. So first is the voltage matrix V1, V2. This is the impedance matrix Z11, Z12, Z21 and Z22. And the third is the current matrix. So this can also be written as V is equal to matrix V is equal to matrix Z into matrix I. Now we have to find each of these Z parameters. So for finding the Z parameters, we will set one of the ports open circuit. We'll open circuit one of the ports. So if we want to find Z11 and Z21, we will open circuit the output port. That is, we'll set the output port which is I2, current at the output port which is I2 equal to 0. So for finding Z parameters, we are setting the current I2 equal to 0. That is, we are open circuiting the output port. So the equations are, it is V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So if we set I2 is equal to 0, that is, if we open circuit the output port, then the first equation becomes, this equation becomes I2 becomes equal to 0. So this equation becomes V1 is equal to Z11 I1, or we can write Z11 is equal to V1 by I1 with I2 is equal to 0. And in the second equation, I2 becomes equal to 0. So this becomes V2 is equal to Z21 into I1. So we can write Z21 is equal to V2 divided by I1 with I2 is equal to 0. So we have got the two Z parameters. Now we will set the input port open circuit. So that is I1 is equal to 0. We are going to open circuit the input port. So this Z parameter equation becomes V1 is equal to Z12 I2. So from that we'll get what is Z12. So Z12 is equal to V1 by I2 with I1 equal to 0. And next from the second equation we'll get Z22. So Z22 is equal to V2 by I2 with I1 equal to 0. So this is how we'll find the Z parameters. And Z11 is called the open circuit driving point input impedance, because V1 by I1 is the impedance and that impedance is the impedance of the input port, And this is called the driving point impedance because this V1 and I1 belong to the same port, that is both belongs to the input port. So this is called the Z11 is called the open circuit, I2 is equal to 0. So this is the open circuit driving point input impedance, and Z22 is the impedance of the output port by setting the input port open circuit. So this is called the driving point output impedance or open circuit driving point output impedance. And Z12 is the voltage at the input port divided by current at the output port. So this is the open circuit transfer impedance. Transfer impedance because voltage is of the first port and current is of the second port. So this can be written as open circuit transfer impedance, and this is the reverse transfer impedance because this is a ratio of input to output. So this can be written as open circuit reverse transfer impedance. And Z21 is the ratio of V2 by I1, that is the ratio of voltage at the second port to current at the first port. So this is also the open circuit transfer impedance, and here it is the ratio of output to input, so it is the forward transfer impedance. So this can be written as open circuit forward transfer impedance. And the unit of all this Z parameters are ohm because it's all V by I, so the unit is ohm. Now we can draw the equivalent circuit for Z parameter representation. Or it is also known as Z parameter model of a two-port network. Z parameter model for a two-port network. So our equations are V1 is equal to Z11 I1 plus Z12 I2. So I am taking the right hand terms to the left hand side. So this becomes V1 minus Z11 I1 minus Z12 I2 equal to 0. And the second equation is V2 minus Z21 I1 minus Z22 I2 equal to 0. And you can see that these two are KVL equations. So we can draw the equivalent circuit. So the voltage at the input port is V1. So V1 minus the current entering the input port is I1. So V1 minus Z11 I1. So Z11 can be represented as an impedance. So this box represents the impedance Z11. So V1 minus Z11 I1. Now we have to represent Z12 I2. So this is also a voltage since it is Z into Y. But this depends on the current at some other point of the network. So it can be represented by a current controlled voltage source. So this is Z12 I2. This is a current controlled voltage source. So this is the first equation. Now the second equation is V2. So the voltage of the output port is V2. So V2. Current is I2. So V2 minus Z21 I1 minus Z22 I2. So here we can represent Z22 I2. This box represents Z22. So this becomes V2 minus Z22 I2 minus Z21 I1. So this is also a voltage, but this depends on current at the input. So this can be represented as a current controlled voltage source. So we can draw a current controlled voltage source over here. So this is Z21 I1. So this is the equivalent circuit for Z parameter representation. And Next, we will see the admittance parameters, that is the Y parameters. So this impedance and admittance parameters are usually used in the synthesis of filters, and also they are useful in the design and analysis of impedance matching networks and power distribution networks. You will see all those later. So that's all about Z parameters. Thank you.